G'day Pure Maths 3 students, this is week 8 of our maintenance. I did notice after I'd recorded last week's work that I hadn't quite finished off one of the questions. I can't remember what question number it was, but I was meant to find A and I found L in A. So obviously all I need to do to find A, once I know what L in A is, go A is equal to, and I'm going to put each side to the power of E, so E to the power of, so I go e to the power of 1.03, and that ought to give me the correct answer for what A is. So 2.80 to significant, sorry, to 2 decimal places, which I think is what we're looking for. So yeah, sorry about that, 2.80. All right, anyway, on to today's work. So we are given a polynomial, and we know A and B are constants, and we know that x minus 2 is a factor, and we know there's a remainder of 4 when we divide by x minus 1. Now, if x minus 2 is a factor, that means that 2 is a root. So if we pop 2 into px, we know that it's equal to 0, and so that means that 2 cubed plus a into 2 squared plus b into 2 plus 6 ought to equal 0. So that gives us 8 plus 4a plus 2b plus 6 equals 0. And you can see we could probably just divide everything by 2. Now 8 and 6 is 14, so when I divide that by 2 I get 7 plus 2a plus b equals 0. And maybe if I want to just put it in terms of b is equal to negative 2a minus 7. I think that's probably about right, hopefully. Now, when I divide by x minus 1, so when I go p1, I've got a remainder of 4. Alright, so let's chuck that in. So we're going to go 1 cubed plus a into 1 squared plus b into 1 plus 6 equals 4. Now this gives us 1 plus a plus b plus 6 equals 4. And we just gather everything together, we get 7. Take that 4 away, so I think it's 3 plus a plus b equals 0. Now, since we already have worked out what b is equal to, I could insert that into this formula over here. So let's do that. So we get 3 plus a, and then minus 2a minus 7 equals 0. Now when we work that out, we'll go over to here. We get negative a, so we get a, what's that? Minus 4 minus a equals 0. So minus 4 equals a. I think that's what we want. Okay, and therefore b is equal to 2 times minus 2, so we're going to go over to this formula here, minus 2 times a, so minus 2 times minus 4, which is positive 8 minus 7, so I think b is equal to 1. Okay, now in the second part of the question, we've got to find 2 other linear factors. So since we know that the equation is, we've just worked out that a is, what did we say a was? Minus 4. And we found out that b is positive 1. So we can write the equation. Now, I will use the long division method. To see if I can solve this. X cubed minus 4x squared plus x plus 6. So all we're doing there is just inserting those values into our equation. Now, when we do that, we'll go x squared, it's our first one, so that'll give us x cubed minus x squared, and then we subtract those, we're going to get, what does that end up being? Minus 3x squared, I think. We bring this x down, so plus x. So we're going to times it by minus 3x, which would give us minus 3x squared plus 3x. Now we're subtracting all of that. And so I think this gives us, it's alright, yeah, yep. So we should get minus 2x, I think, minus 2x. We're going to bring that 6 down. And we're going to times it by minus 2. So you get minus 2x plus 2. Now, this does not look good to me because I must have made a mistake. So, because x minus 1 is meant to be a factor. So let's just have a quick squiz through. Oh, it's not x minus 1 that's a factor. Okay, I've put the wrong one in. So we'll just go back. We'll change this to a 2. And I'll have to do a few alterations as we go. Sorry about that, team. So in the first case, what would that give us? Get minus 2x squared. And so when we add that on, that would leave us with minus 2 here, minus 2x squared. We pull down the x. And then we would probably want to times this by minus 2 then, wouldn't we? So that would give us minus 2x squared, and then this would be positive 4 here. This is pretty bad, guys, sorry. So that's a 2. Oy. 2 and 4. 2, 4. Okay, and then when we do that, so it'd be minus, this would become minus 3, which would mean we'd need to times this by 3 here. So we'd get 3x plus 6. There we go. Okay, so don't be like me. Be careful. As Pakawat would say, read the jolly question. Okay, so that means we now know that x minus 2 into x squared minus 2x minus 3, right, that they're factors. So now we can factorize that second bracket, and when I factorize that, I'm getting x minus 3. Gee, I feel like I've done this one before. X plus 1, and there we go. So those are our other linear factors, this one and this one. Okay, all right, so moving on, and we've got to find the greatest and least values of x satisfying this inequality. So again, I'm just going to use that squared method. So I'm going to get, when I square the left hand side, I get 4x squared minus 4x plus 1 is less than or equal to 25. We bring everything across, so we get 4x squared minus 4x minus 24 is less than or equal to 0. Divide everything out by 4, so we get x squared minus x minus 6 is less than or equal to 0. And I could factorize this, I think. What could we do? I think we need a minus 3 plus 2. Now if we were to sketch this graph, this quadratic, so we got crossing point here at 3, crossing point here at minus 2. So something like that, right? That's pretty poorly drawn. And we want less than or equal to 0. So when we're talking about less than or equal to 0, we're talking about this bit here, aren't we? So therefore, minus 2 is less than or equal to, oh, wait a second, read the jolly question. The greatest and least values satisfying this inequality. So the greatest is 3 and least minus 2. Okay, read the jolly question. Nextly, we have a logarithmic question we can write. So first of all, we've got to write this as a single logarithm. So we use our log rules. Log base 2 of x plus 2 over x. Now, we're going to use that to solve this equation here. So we've got to make that equal to 3. Okay, so all we need to do, log base 2 of x plus 2 over x equals, and now we've got to take log base 2 of what is 3. Log base 2 of 8 is 3. Okay, just go back and think about that for a minute. You know that 2 to the power of 3 equals 8. So to put that in log base 2 form, log base 2 of 8 is equal to 3. Okay, which is what we want. We want to replace that 3. And therefore, once we get to log blah equals log blah, then we can just turn this into a equation without logs, and so we get x plus 2 equals 8x, so 2 equals 7x, so x is equal to 2 over 7, 2/7, and that will be our answer for that. I hope that one makes sense. Let's move on. Here we go. We've got to solve this to 3 significant figures. Okay. My first step, I think what I will do a lot is I'm going to divide the whole thing, both sides, by e to the power of x. Okay, just to make things a little bit easier. So I'll get 1 plus e to the x equals e to the 2x. And you might be thinking, what the blazes did he just do? Is that some kind of black magic and sorcery? Well, no. E to the x over e to the x is 1, right? So that's that bit there. E to the power of 2x over e to the x is e to the x. Now, why is that? Well, because e to the power of 2x is like e to the x times e to the x, right? Using your index laws. So if we've got that over that, we can just cancel one out, right? So that's what I'm doing. And then same idea with e to the 3x is e to the x times e to the x times e to the x. So that's all I've done. And now I'm just going to bring everything over to the right-hand side. So I get e to the power of 2x minus e to the power of x plus 1 equals, oh, right, okay, there we go, minus 1, sorry. Now you can see this is like a quadratic, so I might just even use a substitution at this point. U equals e to the x, and let's substitute that in. So we've got u squared minus u, oh, that's a 1, minus 1 equals 0. And so we can use a quadratic formula at this point. U equals minus 1 plus or minus square root minus 1 all squared minus 4 times 1 times minus 1 all over 2 times 1. Okay, now. Okay, so I'm just going to chuck that into my calculator, but I've written it out so I'd get any method marks if I needed that. What have we got here? So A is 1, B is minus 1, and C is minus 1. So I'm getting my two values for U. U is equal to 1.618033989, or negative 0.618033. That's a 3, by the way. Can you see that? 9887. Okay, now we can ignore that second one. Why can we ignore the second one? Because e to the power of x, which is what u is, cannot be a negative number. Okay? Because the e to the power of anything, it's this graph here, isn't it, right? So it never, it's undefined for a negative number. So we can get rid of that. And therefore we can say that e to the power of x is equal to 1.618 blah 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 blah. Now, how do we find that? What that is equal to? Well, we go take ln of both sides. Ln of e to the x equals ln 1.618 blah blah blah, which means x, so they cancel each other out, cancel the effect out. So we get x is equal to mode ln 1.61833, use the unrounded number, and I'm getting 0.481 to 3 significant figures. Okie dokie. So I've got a trigonometry question at this point. Now I'm just going to go back to last week's thing because this should have the information that we need for this. Okay, so this you will be given in your sheet in the exam, the formula sheet. So this is an addition formula for tan, and that means we're going to need to use it. So let's go ahead and try that now. So I'm looking at this formula here. So the addition formula, so I'm going to go tan 45 plus tan theta all over 1 minus tan 45 tan theta equals, now we do we're doing a minus here, so this one will be slightly different. That should be like that. I don't know what I did there. Brain not working. Tan 45 minus tan theta all over 1 plus tan 45 tan theta. Okay, that's a theta, by the way, as you can clearly see. Okay, so tan 45 we know to be 1, so that makes our next line rather easier. Tan theta over 1 minus tan theta equals 1. Oh, we should have 1 plus tan theta there, sorry. 1 minus tan theta over 1 plus tan theta. So we're going to multiply the denominators to get them across to each side. So on the left hand side we'll have 1 plus tan theta, and that ought to be going into 1 plus tan theta equals, and then on the other side we have 1 minus tan theta times 1 minus tan theta. I guess so, so we're going to go squared. Okay, so what does this give us? Well, let us see. So 1 plus 2 tan theta plus tan squared theta equals 1 minus 2 tan theta plus tan squared theta. Let's gather everything across to the right hand side. So you can see we get rid of these. When we bring everything else across, all we'll be left with is 4, hang on, 4 tan theta equals 0. So tan theta equals 0. And then from our graph, I hope I haven't made a silly mistake here, right? So the two places it equals 0, this is 90 here, isn't it, at the asymptote, and this here is 180. So it should be therefore theta equals 0, and oh, well, if we look at this information here, there are actually no answers in that interval because 0 is less than theta, so, and 0 is less than 180. It seems maybe like I perhaps have made a mistake at that point, but if this remains on the video, I haven't, because I would have fixed it up if there was a mistake for you guys. Okay, if I'd noticed it. Okay, moving on. So the next one is differentiation, and this one here is the quotient rule, which we used last week. So I'll just grab that. Here it is. Here's our quotient rule. Come back, quotient rule. So this is how we differentiate something where we've got a term on top and a term on the bottom of a fraction. So we're going to say that u is equal to the top, which means that du dx is equal to 2. And we'll say that v is on the bottom, so dv dx should be equal to 4x. Now we're ready to use this formula. So dy dx is equal to v, which we know to be the bottom, so 2x squared plus 1, and that's multiplied by du dx, which we happen to find is 2. All right. Minus u, now u is the top, so that's 2x minus 3, and we're multiplying that by dv dx, which we happen to find to be 4x, and all of this ought to be over v squared, so we take the original v, which is 2x squared plus 1, and we'll just put a brackets in the square. Now we can simplify this out. I'm getting on the top 4x squared plus 2 minus 8x squared plus 12x, I think. Plus 3. Yep. Okay. And I guess we can simplify that probably as well. 2x squared plus 1 all squared. And let's go down another step. At this point, I think we'll go, we'll get negative 4x squared plus 12x plus 2 all over 2x squared plus 1 squared. And maybe you might even say, well, let's make it like this, 2 into, and maybe we'll go 6x plus 1 minus 2x squared, or something like that, to factorize that top bit. 2x squared plus 1 squared on the bottom. Alright, that takes us to the end of week 8 maintenance. Hope this has been helpful for you this term. This is all we're doing for maintenance this term. We'll move on with some more questions next term. Keep studying over your holidays though. Alright, take care.